notification on the top of your screen.
आएगी मैम.
Start.
Good afternoon everyone to my dear friends and respected ma'am. My name is Kosthi Akash and today's our discussion topic is SQUID. So what is meant by SQUID? SQUID is device that can detect and yes ma'am.
આકાશ એક સ્લાઇડ લઈ અને તમારો મોબાઈલ જો વર્ટિકલ હોય તો એને હોરિઝોન્ટલ શિફ્ટ કરો સો એવરીબડી કેન સી ધ સિંગલ ફૂલ સ્લાઇડ ઓન ધ સ્ક્રીન. You make it horizontal, rotate करो तुम्हारा मोबाइल में. Select the first slide. हाँ, now you rotate your mobile. અને presentation આપો. જુઓ presentation નો symbol આપેલો છે તમને. No.
Slide માં right side.
Right away with the slide.
એક ટીવી જેવો દેખાય છે ને એના પર ક્લિક કર.
ટોપ સિમ્બોલ છે તે.
આપણે YouTube માં કેવો હોય છે ટ્રાયેંગલ એવો ટ્રાયેંગલ આપેલો જો હા કરેક્ટ. Yes, this is perfect.
What is meant by SQUID? SQUID is device that can detect an even very small amount of magnetic field. It is a very sensitive device in nowadays, enough to measure the magnetic field as low as 5 into 10 raised to minus 4 Tesla. So here one more question is there, that what is the full form of SQUID? SQUID is stand for Superconducting Quantum Interference and Device. SQUID it stands. There are mainly three key for quantum mechanical effect for operations of SQUID: superconductivity, Josephson effect, and magnetic flux quantization. Superconductivity, it was discovered on 8th April 1911 by Dutch physicist J.K. Ons. While trying to measure the residual resistivity of mercury at liquid helium temperature. This man takes the mercury and decrease its temperature up to the liquid helium temperature, and he found that the mercury has the zero resistivity and and it can travels without any losing the energy and with a zero resistivity, and not in even the mercury and many other metals. He found this type of topics, and these metals is named as superconductors. Here you all are able to see this the resistance versus the temperature graph. And this allows the perfect efficiency without energy losses with zero resistivity. Josephson effect, a junction which is made by sandwiching a thin layer of non-superconductor by two superconductor. Due to this junction, the effect is produced. That effect is said to be as Josephson effect. In this Josephson effect, the Cooper pairs are also there, and you all are see this. On both sides there are these two superconductors, and even where the junction is made with the non-superconductor. Magnetic flux quantization. The quantization of magnetic flux is observed in superconductor when a type 1 superconductor is placed in magnetic field and cooled below its critical temperature. It excludes all magnetic flux from its insides. This is called as the Meissner effect. There are two types of SQUID: direct SQUID and radio frequency SQUID. In short, we are RF SQUID. Direct SQUID. It was invented in 1964 and it has two Josephson junction in parallel of superconducting loop. आप सब यहाँ देख सकते हैं ये रेड और ब्लू कलर के बीच में जो येलो कलर की दोनों बाजू लगाई हुई है वो दो जोसेफसन जंक्शन है उसके अंदर. और डीसी स्क्विड इज मोस्ट sensitive magnetic flux available with enormous frequency response extending from DC to a few gigahertz. It has been that energy resolutions of low inductance SQUID operating at 4.2 Kelvin can approach the quantum limit. RF SQUID. It was invented in 1965. It was based on AC Josephson effect and used only one Josephson. It less sensitive compared to DC SQUID and cheaper and easy to manufacturing. RF SQUID is inductively coupled by resonant tank circuit depending on the external magnetic field. As this SQUID operates in the resistive mode, the effective inductance of the tank circuit changes, thus the resonant frequency of tank circuit. Applications of SQUIDs. Most of the applications of SQUIDs is used in the medical term. One of the device most promising use in magnetoencephalography, in short MEG, the process of measuring magnetic field to enable brain imaging. Superconductors are used to make the most powerful electromagnet known as MAN, including those used in MRI machines, magnetic resonance imaging, and the beam steering magnet used in the particle in accelerator. Most of these superconductors are used in the uh, medical term, and some of these are in the geological terms. Ma'am, over.
Yes, Akash.
Over,
Fine. Yes. Fine. You have explained the things like tunneling effect. You have explained the quantum. What? Quantum?
Superconducting quantum interference device.
Okay. But for that, you have given the figure, right? In which the levitation or the repulsion is showing. You have used there one quantum word. What was that? Akash, do you get me? Quantization. Have you used the word, Akash?
Yes, ma'am. Audible now?
Yes, audible. Audible.
Yeah.
What word you have used? That is what I am asking.
Quantization means the number of field which is passing through that the magnet.
Perfect. Yes. Right. Can you go back to your slide in which tunneling effect picture is given? The
This, ma'am,
schematic for tunneling effect is given.
this, ma'am.
Tunneling effect. No. The wave-like pattern you have shown initially, I think.
This.
The first or second slide. No. Before that. True. This one. No. Okay, then yes. એમાં જે middle Josephson effect વાળું છે ને tunneling effect that I am
Yes,
asking.
that's the one type
Will
of.
you explain?
Yes, bolo.
Please explain this in a detail if you know.
Ma'am, these examples of that Cooper pair, which one we are discussed in the last session. Here, these both electrons of Cooper pair. Are you able to see here?
Yes, we are able to see, Akash.
This, ma'am, these both electrons were come in the superconductors, and in between the non-superconductor, this junction, they were not able to pass easily. So these Cooper pairs are in one superconductor and travel from this another superconductor, and these Cooper pair electrons are attract the protons positive charge, which are near to each other.
Okay, fine. Yes, anybody has any question to Akash? Does anyone have any question to Akash? Vishnu, you have raised your hand. What was it? Vishnu?
Ma'am, Josephson effect.
Yes. You want to add something in that, Vishnu?
No, ma'am, I want to know, miss. Ma'am, I raised the hand in जोत्स एंड इट मैम जोत के टाइम पे रेस किया था और अब जाके रेस हुआ हैंड, वो भी पता नहीं कैसे।
चलो डेट सही सही, रेस तो हुआ हैंड। ज्योत को क्या पूछना था?
मैम वो तो नहीं, वो क्लियर हो गया।
अच्छा गुड। एंड फॉर दिस टाइम यू वांट टू आस्क समथिंग टू आकाश?
यस मैम, जोसेफसन इफेक्ट एक बार हिंदी में समझाना ना।
यस
आकाश, टास्क फॉर
यस
यू।
मैम। जो जोसेफसन इफेक्ट है इसके अंदर ये आप देख सकते हैं कि ने दो इलेक्ट्रॉन्स है पेयर के अंदर आ रहा है फर्स्ट लेफ्ट हैंड साइड से, वो सुपर कंडक्टर्स के अंदर है बरोबर।
हाँ।
तो ये जो दो इलेक्ट्रॉन आ रहे हैं आपको पता होगा कि ना इलेक्ट्रॉन के ना ऊपर ऊपर अपने पॉजिटिव चार्ज थे, तो वो पॉजिटिव चार्ज को ना इलेक्ट्रॉन अपनी तरफ ना अट्रैक्ट करते हैं, खींचते हैं। वो जैसे ही अट्रैक्ट करते हैं ना तो उसके आगे वाला है ना दूसरा पॉजिटिव चार्ज होता है वो है ना इलेक्ट्रॉन को अट्रैक्ट करने में रहता है। तो इस तरह के है ना वो अपने ट्रैवल है ना प्रोपोगेशन करते हैं। और बीच में आप ये जंक्शन देख रहे होगे जो ग्रे कलर से है ना उनको हाईलाइट किया गया है, उसके अंदर से है ना वो ट्रैवल होके लेफ्ट राइट हैंड साइड में आ जाते हैं दूसरे सुपर कंडक्टर के अंदर। और सेम ऐसे उसके नीचे जो कुपर है, कुपर पेयर दी हुई है, वो ऐसे राइट हैंड साइड से लेफ्ट हैंड साइड में जाते हैं। और ये जो इसके द्वारा जो इफेक्ट होती है उसे जोसेफसन इफेक्ट कहते हैं। और जो बीच में जो नॉन सुपर कंडक्टर है वो जंक्शन है और उस जंक्शन को कहते हैं जोसेफसन जंक्शन।
तो ये जो नॉन सुपर कंडक्टर होता है वो भी सेम मटेरियल होता है सुपर कंडक्टर वाला के अलग
हाँ,
मटेरियल होता है?
वो अलग मटेरियल होता है उसका। अपने
ओके।
जो क्रिटिकल टेम्परेचर होता है ना वो इस इन दोनों के क्रिटिकल टेम्परेचर से डिफरेंट होता है।
वैसे नहीं, जो हमने जो सुपर कंडक्टर बनाने के लिए मटेरियल यूज किया है वही मटेरियल
ना ना,
टीसी
अलग
ज्यादा
अलग,
मींस टेम्परेचर ज्यादा पे
अलग
यूज
अलग
करते हैं?
अलग अलग मटेरियल होता
ओके।
है। और कुछ?
ओके, क्लियर।
थैंक यू मैम। मैम
Yes, Akash. Yes, just a moment, Akash.
ओके मैम।
Hello.
Yes, Akash, I'm here. Wait a moment. Yes. Am I audible, everybody?
Yes, ma'am.
Yes, ma'am.
Fine.
Yes, ma'am.
Yes, Vishnu understood. Vishnu?
Yes, ma'am.
Have you understood?
Yes, ma'am.
Fine. Akash, you have tried very nice, huh, Akash? Good.
Thank you, ma'am.
I want to, yes, very nice, very good. See, let me.